Welcome, everyone. So today we're going to talk about the spatial navigation library. Well, sorry, we're not going to talk about it. We're going to build our own. As, as you already heard, my name is Sergio Avalos, originally from Mexico, now living in Sweden since 2009. I'm a husband, father, and a parent of a very stubborn sausage dog. And when I'm not running after any of them, I'm also working as a front-end developer at Spotify, where about a year ago, I joined the team that developed the Spotify client that runs on the Smart TVs. That is, although this is a JavaScript conference, we won't be talking about the mobile, we won't be talking about the desktop, and especially, we're not going to be talking about the mouse. Instead, we're going to be talking about the TV control. Yeah, that boring device that I bet every of you have at your living rooms. So, spatial navigation is nothing else than just a fancy name to describe what you do with the arrow keys when you select one of the app, open it, and then navigate within. I guess as most of you, during my whole career, I've been working with mobile and desktop applications. So when I joined this team, I decided to pick on those topics that were particular to this new device. And I didn't need to go too far. When I started diving into the source code, the first thing that I noticed is that my company developed an internal library for building this functionality. So I decided to take a look into the source code, and immediately I was fascinated. Not because the code was great, I mean, the code was fine. I would probably put a little bit more comments and so on, but what I really thought it was very interesting, it was the problem scope. It just didn't occur to me that this is something that someone can get a lot of fun. So this is what this session is about. I want to guide you through my learning experience as I was learning about this problem scope and how it can be solved. But again, what a better way to learn than building it ourselves. But first, as many of you, every time you start a project, you have to ask yourself, why? Why do you build a library? And especially in this case, because if you are building an application for a smart TV, shouldn't that be provided by the platform? And the answer is yes, if you were building a native application. Let me try to explain. If you come to the market for the smart TVs, it's quite segmented. By the way, raise your hand if you work with the smart TVs. Yeah, there you go. Let's talk. No, but it's really quite segmented. It's not like mobile or desktop where you have like 2 or 3 maximum. No? Instead, you have all these brands that each of them run their own operating system. And for that, yeah, there is no way around. You need to build your own application system. So for us developers, to make our life easier, we decided to build the user interface using a web application that runs internally in one of the native applications. That makes our life a lot easier, but obviously it wasn't free. It came at a cost, and that means that we lost the support from the platform. So then I was thinking like, okay, but isn't it that supported by the web browsers? It's the year 2023. The browsers are a very sophisticated piece of software. Isn't it the functionality there already? And the good news is like, not yet. There is a proposal in the W3C consortium, for like adding this new API, but it's not there yet. It's still a draft after 2019, so that means that we need to continue waiting. I was like, okay, but there must be an open source project out there, no? And now there is, and thank you, Norwegian Media, for providing that. Sadly, they released, well, not sadly, but they released their first version back in 2020, and our application is a lot older than that, so we were on our own to develop it. So, having answered that question, that we were not wasting our time, we can start building our own. But how would you build it? If like I would ask you from top of your head, like what is the first thing that comes to your mind? I don't know about you, but the idea that I had, and it's funny because it's the same approach that I read on the Norwegian Media site, and I think even on Netflix, the first approach that we all came up is, for example, if you take the Spotify application and then you just look at the sidebar, remove all the image and styling and so on, and you just get the skeleton. And for each of these components, then you have a link element, HTML link, where you wrap each of those elements with a navigational node where you add a unique identifier, and you simply, in that navigation node, you tell them where to go, depending on that. And yeah, as simple as that. This actually gets the job done. The only thing, as you can already see, is that it has a few caveats. First one is that it's very difficult to work with dynamic views, and Spotify is all about recommending you the right playlist for the right time and the right moment. So as a front-end developer, you don't know what the data you're going to get. So it's not impossible, but it's more difficult to work with. It's error-prone because you need to add those unique identifier manually. So we're humans, we make mistakes. And finally, there is a lot of extra information that has nothing to do with the view, and it just makes the developer experience more difficult. Fun fact, I heard a story that people who will be new to the project, that who will join, I mean, they will just join, they will pick the easy task of like just doing some styling, and when I look at this, they wouldn't know where to put it, so they will put the CSS properties on the navigational node, and we were like, no, that's not for that. It's like, well, how are they supposed to know, no? So we decided to improve it. To demonstrate this, I decided to create a very simple demo site. Works fine, yeah, perfect. So this site has just 2 pages. It has the first 10 links that you can see here that I'm selecting. I click on one of them, and then a random gift appear. It also has a go back link, and then we start. It's extremely simple because I want to focus mostly on the functionality of integrating this with the TV control. That you can see it works with the mouse, but it doesn't do anything when we click on the TV control. All right. Just because I want to make it, Just because I want to make it crystal clear, I'm going to guide you really quick through the code of this demo site. First, we have the script that we get from the Create React app that I'm sure all of you are familiar with. In it, we are rendering the app React component. That is nothing else than just the router configuration for the 2 pages that I showed you before, the welcome and the surprise. We're using React router library for this. And then for the pages, we have, again, another 2 React components. For the first one, the welcome, we have an array of 10 empty elements that we use it only to iterate and render the question boxes. And for the surprise page, we already have hard-coded the link to the images, where we pick one randomly, and then we render in along with the navigational link to go back to the previous page. Finally, we go to the link elements. That, again, is another React component that both are using the link component coming from the React router library. And in the first case, we only wrap the question box, and the other one, we wrap the children. It's usually just text. So this is just the demo site. We haven't gone to the library. For the heuristics of the library, the first thing that we're going to do is register the navigational nodes. That means what elements the user can interact with the arrow keys of the TV control. Then we listen to all the events coming from the TV control. Once one of the directional keys is pressed, then we find the selected node, depending on where the cursor is and where should it go. And finally, we just update the cursor just to indicate now which element has to be selected. If you look at the diagram from the step 1 to 3, you can see that we have a new instance called the navigation engine. That's going to be our class that has 2 methods, one for adding these navigational nodes, and the other one for handling the events coming from the TV control and executing the handle navigation method. All right, step number 1, register navigational nodes. In our schema, for each of the navigational nodes, we're going to have 2 properties, the ID and a reference to the actual HTML element that we're rendering. Then we create the class with a private variable, nodes, where we put all the navigational nodes that we are registering, a method for adding values to this private variable, and another one for removing it. Then we go to the script, our script file, where we create an instance of this navigation engine. For the purpose of this demonstration, we add it to the global scope. We don't do it in production, obviously. And then we make it available through our old app, creating a React context. We go then to the link element, where we're going to be calling a hook function that we're going to create in the next step. But for now, what you need to know is that we got two values. The first one is a callback to set the reference value to the HTML element that we're rendering, and another one that is a Boolean value that tells you whether that element in turn is selected or not. Finally, for this step, we create the hook function where we create this reference value along with the callback to set it whenever the component is rendered. We create the unique identifier, obtain an instance of the navigation engine, and finally, with the help of the useEffect function, whenever this component is mounted, we call the register node, and whenever it's unmounted, then we'll just remove it. We have a final value called this focus, but for now it's going to be hard-coded, and we're going to update it with the real value at the end of the step. Okay? So now we can go and test it. Can you see on the back the console log? Yeah, everyone. So if we inspect the nodes private variable, then you can see that we have all the nodes. And if I inspect one of them, you can see that it actually points to the right reference. I click in one of them, and these have to be refreshed accordingly. And then, yeah, you can see that the reference is the same one. I can even do this. And then you go back. Cool. All right. Step number 2, we listen to the events coming from the TV control. And in this one is one of the easiest steps, where we just need to add an event listener to all the events coming from the document for the key down, where we attach a callback function that we obtain from this method called getKey event handler. And that function, what it gives us, as I said, it returns a callback function where we detect if the event that it was triggered is one of the arrow keys from the TV control. And we have already a map between the values from the platform, the native platform, and the internal values that we use in the application. This step is not really necessary because we're running on the desktop, but I felt it was important to highlight because this is one of the tasks that the native application have to do to connect our web application, the UI, with the platform itself. So we're going to test it real quick. You can see that when I you can see that in the event, it's probably very small, but you can see that I have the down arrow here. If I go to the up, left, and etc. So cool, we're done with this step. We can move to the one that I think is the most interesting one. Once one of the arrow keys has been pressed, then we need to decide which one is the node that has to be selected. In case you were wondering, like, why do we need to keep a reference to the HTML element, it's because we can call this function, getBoundingClientRec, that gives you the dimensions and the coordinates according to the viewport, wherever this element is rendered. That means that if you take the list of all the navigational nodes that you have saved so far, and you call this function to each of them, then you get the dimensions, as I said it, and the coordinates, and that's all the information that you need to decide where the focus should go next. So you can forget about what you are rendering. This is all the information that you need. So with that information, how do you choose the next node? First, you filter by the direction of the key that you are pressing, then by the main axis of the current element that you have, and then you just pick the closest one. So for example, if you have an array of 5 by 5 and the cursor is sitting exactly in the middle, when you go to the right, then you select the last two columns, where if you are going, if the key of the TV control that I was pressing was the up, then the top, then you select the first two rows of that. From those, then you choose by the main axis. So if you are going to the right, it's those nodes between the margin top and the margin bottom. And if you're going up, is the one between the left and the right. And finally, you just pick the closest one. So how does this look in code? We go back to the navigation engine class. You create a new method called handle navigation that does exactly that. First, it filters by the direction. And to filter, we already have a map that points between the direction of the key and the filters that you need to use. We follow exactly the same pattern where you are filtering by the main axis. You pick the closest node, and then you update the private variable of the selected node with whichever node you have obtained. And finally, we replace the console log that we had before for debugging purposes with the new method that we just created, handle navigation. Cool. So we just go and test it real quick. If you see, initially, the selected node, it's undefined, but when I press down, then it updates with the selected node, and then again. So cool. We are handling the navigation, but the cursor is not visible yet. So that's what we need to update next. If we come back to the diagram, the only thing that changes is that whenever we register a new node, we need to add a subscribe method so that the nodes can be notified whether they were selected or not. And then we update the handle navigation to notify each of those elements. So in our navigation class, we add the new method for like registering callbacks whenever that happens. We add one method for like executing all those callbacks, notify all subscribers, and then we use it after the handle navigation has been executed. We go back to the hook function, our hook function, the use focus ref. We remove the hard-coded value that we have with another hook function called use node focus, where we have a local value, a local state. It's a Boolean that tells you whether that node is focused or not. And with the help of a use effect function, whenever the component is mounted, first we check if that component is already focused, and then we subscribe. So whenever there is a handle navigation happening, we check again, like, okay, am I the node that is supposed to be focused or not? To avoid memory leaks, we have to unsubscribe whenever we unmount. And cool. The basic requirements are done. You can see that it's selecting properly. I click in one of them, and no. No, wait. I was drinking water, you know. No, but I mean, the real. Are you ready for a challenge? Yeah. If I told you that this is what got me excited, I will be lying, because honestly, we were just filtering coordinates, and it was just a lot of filtering. It's okay, but I felt it was time to level up. This feature is the one that I think is the total game changer. In case you are not familiar, which I'm sure that you are familiar, but I'm just going to play Captain Obvious and repeat again. There are, when you're navigating on the TV, there are some sections that you want to, where you want to like soft the limits or soft the constraint, meaning that if you're in the sidebar and the user are hitting like down, when they reach the bottom, you want to move the cursor to the very beginning when they hit down instead of asking them to go all the way back up. So this is just a commodity, and I think personally, I think it's a total changer, because if you look at our demo site and assume that, for example, for the lowest row, we want to make it circular navigation, then the list that we have doesn't work with us anymore, because we need to distinguish those nodes that belong to this section or not. So instead of using a list, we need to move to a tree. And now, it's not only about the distance between the current node and the selected node that you're moving. It's also about the relationship in the tree hierarchy that you have. So if I go to the demo site, you will see that I have a new button for a new page where I have exactly the same buttons that I had before, but I want to mark the lowest row as the circular or cycle navigation, which right now it doesn't work. So that's what we're going to add now. So the heuristics for the circular navigation is that first, we need to create a container to say what elements are going to be part of this section and which ones not. Then we will build the navigational tree, so we move away from the list. And now we update the node selection algorithm. For the first step, we create a new view, a new page called the level up, where we reduce the size of the array that we were using to iterate to 5. We run it twice, but for the second time, we're going to use this new component called navigational container. In this navigational container, we call a new hook function that looks very similar to the ones we had before. We create a unique identifier. We also obtain one instance of the navigation engine. But the difference is that we pass the attributes to indicate what is the direction of the cycle that this section needs to follow. Then in our schema, we create a new type for the navigational container where we have the ID and the attributes that we mentioned before. And we update the class navigation engine class to indicate that it's not only navigational node, but also navigational container that we need to use. We're going to test it real quick. So right now, nothing changes because we're on the same page. But if I go to this one, you will see that I have a new element where it doesn't have any reference to any HTML element, but it has the attribute cycle to indicate the direction of this new section. So now we have the container. We need to integrate it in the navigational tree that we were talking about. To do that, we're going to add a new attribute called ancestor ID in each of these elements to indicate what branch they belong to. And to set this value, we're going to create a React context where by default, in our initial app, is going to have the value root because by default, all the navigational nodes belong to this branch. But for the navigational container, we're going to update that value with the ID that we obtain when we register this navigational container. So we're going to test it real quick. Go here. We look at the nodes, and you can see that the first row has the ancestor ID as root, but the other one is a different one that matches this one. Jesus, for a moment I freaked out. I felt that it was not working. No, all good, all good. So far, so good. Great. So now we'll update the selection algorithm. Let's think about the cases that we have. First, if you're navigating within the same branch, the first case that we have is that when you navigate within the same branch. Then the second case is when you're leaving that branch. And the third one, when you leave that branch, but you go to a nowhere place. For the first one, we do exactly what we were doing before. But for the second one, when you're going to a different branch, you have to check if the ancestor has a cycle attribute, and if that attribute matches the direction of the arrow that it was just pressed. And if that's the case, then we find the cycling node. And if not, then we just pick the same one as before. It's almost the same case as the other one. It's just that if it's not the cycle if the direction doesn't match the cycle, then we just ignore the event. So you can see the common denominator where first we find the closest node, but we also need to find the cycling node. To find the cycling node, we're going to imagine, if we come back to the matrix that we had before, that instead of sitting in the middle or wherever you are, we're going to imagine that we're sitting in one of the edges, and it's going to be the one opposite to the direction. So if you're going to the left, then you want to think that you are on the right, and vice versa. So we are going to update the navigation engine with everything that we had before. We move it to a private variable. Once we obtain the closest node, then we compare if it's part of the same branch. And if it is, then work done. But if not, we check if the direction matches the cycle, the direction of the key, matches the direction of the navigational container. And if so, we find this cycling navigation, which is the same approach as we did before. The only difference is that we already have hard-coded the edges of the viewport where we're rendering. With that information, we can easily find the cycling node. And if not, then we just pick, if it's not part of the same branch, then we just pick the closest node. And then we update the value that we had before. So that's it. I'm just going to test it for the last time. I go to the level page up. I select the first node. This one is not cycle navigation. But in this case, we can see that it works. So that's it. This is just the beginning because obviously your application is going to look a lot more complicated than just a simple matrix. You will have rows, you will have columns, and literally you have to deal with corner cases. What about those inconvenient pop-ups that tell you like, hey, do you want to buy premium? No? That's an interesting case because you have the navigation tree and you need to update it with new elements that are coming up. And you also have to focus the navigation to only those elements. So it brings a new challenge. And finally, the elephant the big elephant in the room, performance. This is just a utility, and it's going to take a little overhead of your application, which has, realistically speaking, 9 milliseconds to run to avoid like dropping any frame. So the challenge here is like, how can you minimize that overhead so that it doesn't interrupt your application? But for now, that's all. If you feel curious about this code, everything I've shown you before, you have the code in my personal repo. And I also wrote a blog post in our engineering blog that you can follow up. But if you feel curious about writing your own smart TV application, you don't need to do this from scratch, obviously. You can just use this open source that I mentioned in the beginning. However, if you feel challenged and I think this is way too complicated, please get in touch. I would love to learn from you. Absolutely. That's it. Thank you very much. Muchas gracias.